Hey guys, how's everything going? This is JSer. So I'm writing JavaScript every day, and the JavaScript is becoming more and more complicated every day. It's a good thing, and the JavaScript is more powerful. We can do things we couldn't do before. Well, it's a kind of a bad thing. It's it's hard to grasp it. So yeah, it's not that easy to become a JavaScript engineer. Me too. I'm not that good at the fundamental knowledge of the programming stuff. So in this video, I'm going to try to explain what the finalization registry is. Actually I heard about this like yesterday. Okay, let's just jump straight into it. Okay, let's first see the explanation of finalization registry on MDN. I believe you've heard of the weak map or weak set. I never use it, but I know what it is. Okay. A finalization registry object lets you request a callback when an object is garbage collected. While GC and garbage collection is is something we don't have control of, right? So the browser, the JavaScript engine, might collect just reclaim the memory when it thinks it's suitable. So how it depends, it's been some algorithms I remember uh, it's called what? I forgot the name. It basically means that if the engine cannot reach your code, yeah, even if there are some reference to your object, but if the whole block is not referable, yeah, cannot reachable. Yeah, if it is isolated in a small island, it will be reclaimed. Well, let's forget about that. When an object is reclaimed, actually, we didn't have any. We're not notified yet, right? We don't know. Well, you can like set a timer to interval to check the existence, but that's not very cool. So this finalization registry provides us a way. When the object is garbage collected, you get notified. This is the callback. Okay, so this is the syntax. We created a registry, the new finalization registry, and this is the health value. It's the parameter we set. Okay, then this is callback, and then we call registry, register, and attach this callback to this object. It means this object now has a finalizer. Yeah, finalizer. Now, and we have a method to unregister it. So, yeah, seeing these, actually, I didn't know what it actually does, right? What's the use case for this? Well, I found another article on the internet, and these actually explain the things very well. It's published like in the last year. I didn't know this. Okay, and this article actually explains so well that it covers a little bit of the weak map and a little bit of the real use case for this. Let's just jump into it. Okay, so this is the basics. When we create an object, as long as we have the access to the ref, means this object is reachable. This object won't be garbage collected. Well, this is true. If it is, there's some fundamental problems, right? Okay, now we have weak map and a weak set. What it is? Okay, now we create a weak map, and in this weak map, we set this object, like the ref, right, as a key. Okay, a map has an object as a key, and there's some values. When this object, this is a weak map, so this weak map doesn't have the strong ref to this ref object. It only has a weak ref, which means it will not block the garbage collection. So this ref could be garbage collected, and then the weak map doesn't have this entry at all. So we can set the ref to null, and when it's garbage collected, it's gone from this map. Also the same, right? We add the ref to this set, and this ref could still be garbage collected. Yeah, so this is what weak map and weak set is for. Okay. There's some nodes. I can think you can ignore that. And there's another thing called a weak ref. Weak ref is actually allows us to create create a weak reference more freely than a weak map and a weak set. Let's see what it is for. So now this block introduces with the fantastic example of the use case. Let's see. So this is is a class which will hold the events from the WebSocket, and well, we have this socket, and we attach a listener to the message event. So when the server gives us a message, we will push into this event. This is an array which holds the event, so it will gonna float if we don't clear them up. And this is the listener, right? What it does, push to the event. It's very cool. And this is a component. We do some rendering. We have this moving average instance here. Okay. So now it has a start and a stop. When you start, it will creating this moving average, right? And then when you stop, we thought we could allow the garbage collector to reclaim the memory because this array is dangerous, and so we set it to null, right? We remove the reference to this moving average. We hope to see that this event is only attached to this instance, so it's gonna be a garbage collector, but actually it didn't because there's an event listener. Okay, let's see the graph here. So this is a moving average component with a UI, and it actually has the reference to the moving average the instance, and also it actually holds the reference to the socket, and this socket has this event listener. It's actually a strong reference event listener to this listener, and this listener, well, it has this event, right? So it holds the reference to the event. Well, by holding the reference to this is moving instance, and then this listener. To the moving instance by this, not the event. This. Okay, this moving instance has this listener. So this is the I would say this is a reference map. Okay, so now when we set the moving to null, we cut this reference, right? We cut it, but the event listeners, the reference is still here. So the moving average instance is still there by this like detour. So it's actually the memory leak happens. Yeah, and of course we could manually remove the event listener. Is actually what I'm currently doing now. I'm used to it. Or usually we just like when we're creating a React component, we will remove the event listeners we added by ourselves on the component one mount, right? Well, on a mount, I'm sorry. Okay, yeah, this is a cool, but actually it's manual, so it's prone to mistakes. When we forgot this is gonna be a huge problem. So weak ref actually helps us. Let's just jump right into the map. Okay, oh no, we have to see the code first. Okay, so this is the moving average. We have this listener. Rather than we attach the listeners directly, we say add weak listeners. So what does it mean in this add weak listener? The problem is the listener here, right? So we actually need to make it this weak. So rather than accessing the listener directly, we need to access the weak reference to this listener by using this weak ref. So we create a weak ref to this listener. So actually, weak ref has a weak ref to this listener. It will not block the garbage collection. So now we have this wrapper. We access the weak ref. If it is there, we call, right? We call the listeners. If it is garbage collected, we do nothing. So we use this nullish cleansing operator. Oh, not new. This optional chaining. I'm sorry, optional chaining. Yeah, optional chaining. We add the listener with the wrapper. So now this listener is weak referenced. So yeah, what it happens now is that comparing to the case before, we now have a weak reference here. This is the same. This is the same. This is still the same, but we have this listener to the wrapper. The wrapper is got the reference to the listener by the weak ref. Now when we cut it down, so this is weak. So the JavaScript engine will garbage collect this whole part. So this is gone. It's undefined. Yeah, cool, right? So now if we forgot, yeah, we have this automatically removal of this whole memory, but we still have the wrapper here. This is strong reference, even the listener. While this is just a wrapper, it's a function. It's not an array holding the messages, so it's kind of acceptable. So this is not a huge, it's not a big problem. But actually, we could improve this by, okay, finally we see the finalization registry. Okay, when this we could attach a callback. When these moving instances is garbage collected, we could call the callback, which will detach the listener, right? Let's see what's the code here does. Okay, this is the same. We add a weak listener. Reasonable. In this, we have the weak ref, and then we have this. Okay, listener registry. We create. Wait a minute. Oh yeah, this is a registry. When we attach this listener removal callback here, so we will attach to the listener. So when the listener here is garbage collected, we could remove the listener, right? But with the listener, if we just access the socket and wrapper directly, this actually will hold the strong reference. This is not good, so we pass it down by these parameters. Yeah, so in this we don't hold any reference, right? This is pure function. Cool. So okay, finally we add this weak listener. So now the chart becomes this is the same, but now when it is set on is garbage collected, is undefined. Actually, this will be removed automatically. So problem solved. Okay, let's review this a little bit. We solved the problem. We actually what we want is actually make this weak, right? So when the instance is gone, we want everything to be removed. So the first step is to make this weak. The strong listener make it weak by weak ref to make it weak, and then when it is nulled, and this part will be removed, and the memory will be released, and the callback will trigger by this finalization registry, and we cut here. So it's kind of like action chain, right? The callback. If we cut here, here will be gone, and here will be gone. It's complicated actually. Okay, so yeah, this whole stuff, the combination of finalization registry and the weak ref makes this whole thing possible. Okay, don't overdo it. It's complicated, and maybe you don't need it. Just don't put important logic in this. Only use it to clean up, right? It's finalization registry. Just do some cleanup work. Remove some even listener, or call some not that important API. I think. Okay, so that's it. Hope it helps. Today I learned the new things: weak ref and finalization registry. Yeah, see you next time. Bye bye.